All right, so in addition to working with logs and finding their values, we have some properties that we want to highlight, and then I'll just demonstrate those with a few examples. So if I take log base 3 of 3, 3 raised to what power is 3? The answer is 1. Similarly, if I do log base 7 of 7, 7 raised to what power is 7? The answer is 1. So that leads us to this basic property. Log base a of a is always 1. And so we want to remember that. If the base matches the input, then we're going to equal 1. And that is that's a handy property to make use of. Likewise, if we take log base 3 of 1, the answer is 0. 3 raised to what power is 1, and the answer is 0. Log base 7 of 1, the answer is 0. So that leads to the property log base a of 1, whatever the base is, will always be 0. Log base 5 of 5 to the x, right? It's kind of funny. You're putting a function inside the log function. So log base 5 of 5 to the x, the answer is x. 5 raised to what power? Again, if we play the game, 5 raised to what power right there is equal to 5 raised to the x power. The answer's got to be x. And so we're going to want to use that as a property. I'll just write the property over here. Log base a of a to the x equals x. Now that property is a direct result of not only the definition, but it is also a demonstration that these two functions are inverses of each other, because if you plug one function into the other, you get x. Similarly, if I have, say, 3 and raise it to the log base 3 of x, so I take an exponential function raised to a log function, that will also equal x because they are inverses of each other. So a raised to the log base a of x is just equal to x. And there's our property. All right, let's talk for a moment about domains. We've introduced how to work with these functions. Let's talk about domains. And if you remember what a domain is, it's the values that you can plug in to a function. So what is the domain of a logarithmic function? Say f of x equals log base 2 of x. Well, the answer is quite simple. This must be positive. In fact, it's got to be greater than 0. So in other words, you cannot plug in any negative value into a log. You can't take the log of negative 3, log of negative 5. You can't take the log of 0 because it's impossible to take 2, raise it to a power, and get 0 or a negative number. So in short, domains always have to be positive. So if we have a problem like this, what is the domain of, say, log base 3 of 2 minus x? Okay, we have to make sure that this piece is positive. So all we have to do is we have to say, okay, let's try that again. 2 minus x has to be greater than 0, strictly greater than 0. And so if you solve that for x by subtracting 2 and then dividing by negative 1, you find that x has to be less than 2. So you can only plug in things that are less than 2 into that function. Okay? And so that tells us that you can't take the log of a negative function, and we want to remember that.